Hey guys, welcome to our lesson on 2D kinematics. In this lesson, we will be covering 2D kinematics. Just like in 1D kinematics, we will be using equations to describe the motion of an object. However, instead of looking at an object only moving in a straight line, we'll be looking at an object that's moving both vertically and horizontally. With 2D kinematics, we can describe the motion of things like sports balls and stuff launched from catapults. We'll be covering the three types of projectile motion problems: horizontal, level ground, and unlevel ground. With all that said, let's get right into the lesson. To start off, let's do a quick review of the four kinematics equations. There are four kinematic equations that can be used depending on the context and the variables provided. Within the equation, there are multiple variables such as u, s, t, a, and v, where u is the initial velocity, s is the displacement, t is the time, a is the acceleration, and v is the final velocity. It is also important to note that in the vertical direction, y, the acceleration will always be the one done by gravity, or negative 9.81 meters per second squared, and that the acceleration in the horizontal direction, x, will always be 0 meters per second squared. We will also be dealing with motion in two directions, and in order to properly visualize that, we're going to be using the table on the bottom left-hand side. A horizontal projectile can simply be defined as a projectile in which there is no initial vertical velocity. It can be represented as an object going off a cliff, as shown by the picture on the right. Now let's take the problem based on the picture, where we're going to find the horizontal displacement of a cannonball being shot off a cliff. Here are the values we're going to use. The initial horizontal velocity is 20 meters per second. The vertical displacement, or height, of the cliff is negative 100 meters. Now to go over the implied values. Because the horizontal acceleration is 0, the final horizontal velocity is the same as the initial. The initial vertical velocity is 0. Now let's put that into the table we introduced earlier. Now that we have our values, we can now solve for the horizontal displacement. The most important value to solve for in order to find the horizontal displacement is time, as then all we would have to do is multiply by the velocity. To begin, let's use the third kinematic equation, which is s equals u times t plus 1 over 2 times a times t squared, and plug in the values in the y section into the formula. It is important to acknowledge that the time value in both the horizontal and vertical components are equivalent, so we can use it to figure out the horizontal displacement, as shown below. Finally, assuming that rightwards is positive, we can say that the projectile travels 90 meters horizontally. For this type of projectile, the value of the vertical displacement is 0 because the ground never changes elevation, as shown in the diagram. Seeing as its motion is parabolic, the highest point is in the middle of the parabola, or when the horizontal displacement is at its halfway point. Since the object doesn't go any further upwards than at its highest point, the final vertical velocity is 0. If we take that the initial velocity is 25 meters per second at an angle of 60 degrees above the horizon, and that the total horizontal displacement is 40 meters, at what time does the projectile reach its highest point? The first thing we should do is separate the initial velocity into its horizontal x and vertical y components. To do this, all we have to do is use some simple trigonometry. To figure out the initial vertical velocity, all we have to do is use the sine function, as shown below. To find the initial horizontal velocity, we just have to use the cosine function, as shown below. We can now apply the first kinematic equation to the y section of our chart. The reason why we use the y section instead of the x section is because we are looking at its peak vertical height. Finally, we can find out that the projectile reaches its peak at 2.21 seconds. Unlevel ground projectile is a projectile that has an initial vertical velocity but ends up at a different elevation than where it started at, as shown in the picture on the right. For these problems, the vertical displacement is a critical piece of information. Since we solved for the horizontal displacement and the time previously, let's now solve for the final velocity of the object. In this problem, we'll be using the values presented in the diagram, which includes an initial velocity of 20 meters per second, a launch angle of 34 degrees above the horizon, and a horizontal displacement of 100 meters. The first thing we need to figure out are the vertical and horizontal components of the initial velocity, as shown below. For the y-section, we can use the fourth kinematic equation to help us solve for the final velocity. Because the ball is going downwards, we will choose the negative value, meaning that the final vertical velocity is negative 45.8 meters per second. Now that we have both the horizontal and vertical components of the final velocity, all we need to do is to figure out the resulting vector, as demonstrated by the diagram. To do this, all we have to do is to take the scalar values of the components, no negatives, and use the Pythagorean theorem. Now that we have the magnitude of the final velocity, all we have to do is to find the direction. This is once again simple geometry, as all we need to do is to take the inverse of the value of the tangent function, as shown below. Finally, the final velocity will be 48.6 meters per second, which is 70.3 degrees below the horizon. Thanks for watching. If you want to learn more about physics, math, chemistry, or biology, please take a look at our other videos. I'll see you guys in the next one.